Alright, here we go.
We're gonna lose subscribers on this video.
Subscribe.
God.
Why am I gonna lose subscribers? Are you gonna be in it or something or what?
Because you're mad.
Because you're mad and you're mad. No, I'm really not that mad. Just kind of really mad.
Tell it to the camera. Tell me so.
No, wait, we're recording. Let's go. So we're starting Unit 7, guys.
Oh no.
Unit 7, linear inequalities, right? Absolute value linear inequalities. Guys, stop talking. So, it is our 7th unit. How many more units do we have before the final?
2, 7.
Well, including 7, 2. Right? After this unit, we only have one more, then we have the final. That's how close you are to end of first semester. That's crazy. So, this unit will not be as bad as last unit, I don't think.
Really?
Last unit is probably the hardest one of the semester, I would say. This unit, today especially, is going to be all review. We're going to talk about like inequalities, we're going to talk about graphing inequalities, we're going to talk about graphing sets of inequalities on graphs, things like that. We got all sorts of fun stuff to do. Like I said though, shh, guys, relax. Like I said, today's going to be all review. It should be really easy, should go right quickly. Once we're done with the notes, then we get to see our tests. Which I don't know if that's a good thing or not. No. So, a couple things we're going to do today. We are going to write inequalities and graph them on a line. We're going to review inequalities. We're going to talk about inequalities with and or. And it says matching number lines with inequalities. What that means is we're going to write inequalities based on number lines. Should all be reviewed. Pretty easy stuff today. Alright, so, first and foremost, graphing an inequality. A graph of a linear inequality is a set of points on a number line that represents all of the solutions of the inequality. So that's those first few fill in the blanks. The graph of a linear inequality is the set of points on a number line that represents all the solutions of an inequality. So, you should all know how to do this. If I say all numbers less than 2, if I want you to write that with symbols, how would I do that? What is
No, like the thing that's like
X is less than 2. Hey guys, so you guys use the alligator to distribute less than and greater than? Like, do you guys know the tricks for less than and greater than? Some people use like alligator, some people use Pac-Man. So use alligator because the alligator eats the bigger number, right?
Yes.
Well, if I'm saying like X is less than 2, there's not really, I mean 2 is the bigger number. The way I always remember it, that less than goes this way, because if I look at it, it looks like an L, I can write less inside of it. Right? Greater than would be the opposite way, obviously. So less than I can write less inside. If you need to do that to remember it, you're more than welcome to. If you don't want to, you don't have to. Alright, if I want to graph that, on my number line here, I'm going to write 0, 1, 2, 3, 4. Does your graph need to be exactly the same as mine? No. No, of course not. Right? Does it need to have a set scale? Yes, it needs to go by a certain number, whether it be 1s, whether it be 2s, 3s, 4s, whatever it is. And you also need to make sure your endpoints are on the graph. We'll talk more about this in a little bit. So, X is less than 2. How do I put that on the graph? Someone help me out.
Open circle.
Julia.
Circle like on 2 with an arrow going to the left.
Okay, so you said on 2. I put mine above 2. Why do you think I did that? So it's easier to see, right? I need to be able to see where your graphs are going. If you put them on the number line, they're not always the easiest to see. Can you put them on the number line? Sure, I'm perfectly okay with that, but if I have to guess which way it goes because I can't tell, I'm probably going to guess wrong. You're probably going to mark wrong. Alright, so I always put them above just to be safe, but you do not have to. You can put them on if you want, just make sure I can see them. And then yes, you need an arrow at the end because it keeps going less than 2. Alright, all numbers greater than negative 2 would be X greater than negative 2. So I'm going to go to graph it. I'm going to start at, let's say, negative 4, negative 3, negative 2, negative 1, 0. Well, greater than means it's just an open circle, right? Greater than, I'm going to the right from negative 2. Hey guys, when's it a closed circle?
Greater than or equal to.
When there's that line, or it's or equal to. Or equal to means it's a filled in circle because I can then include that point. I can use that point in my graph and in anything I do. Alright. All numbers less than or equal to 1. Well, x less than or equal to 1. I use a less than or equal to sign. So when I go to do my graph here, let's go negative 1, 0, 1, 2, 3. Less than or equal to 1 means it's a filled in circle at 1. Less than means I'm going to the left. Alright? Any questions on that so far? Are we good?
Yes.
Okay. All numbers greater than or equal to 0. Well, x is greater than or equal to 0. So, negative 2, negative 1, 0, 1, 2. Hey guys, is your endpoint always going to be in the exact middle of the graph?
No.
No, it does not. Mine happens to be here, but it doesn't have to be. So greater than or equal to 0 means filled in circle at 0. Greater than, I'm going to the right. Alright, any questions so far? Alright, then I'm going to keep going. Does anyone know when we flip our inequality sign? Mr. Fields? Partially correct. So it is when you multiply or divide, but it's by something specific. By a negative. So anytime I multiply or divide by a negative number, I'm going to have to flip my inequality sign. Alright, so that means when we're solving these, because that's what we're going to do in a second. When I'm solving, if I have to multiply or divide by a negative to solve, I need to flip my inequality to go the other way. Is all that written down? Where it says the question, when do you flip direction of the inequality symbol?
Yes.
Do the rest of us another second to copy it down. You didn't use Mississippi.
Mississippi.
Okay. Fully good. Okay. Alright, so then our steps to graphing the linear inequality. Right, we're talking about solving. Do all your needed algebra to get the letter by itself. We always say on the left. Am I going to be that big of a stickler if you do it to the right side? Where you have like 3 is less than x. Am I going to mark it wrong?
No.
Probably not. Do I prefer if you get them all to the left side since x is greater than 3? Of course, yeah. But I'm probably not going to mark it wrong. I'm not that big of a stickler about it. So make sure you get that x or whatever variable you're using by itself. And make sure you switch sign if you multiply or divide by a negative. Step 2 then. Determine if the circle is filled in or open. Remember, less than, greater than, it's going to be an open circle. Less than or equal to, greater than or equal to is going to be a filled in circle. We talked about that already. Finally, step 3. Determine if you're going to shade left or right. If I have 2, I'm going to go less than, it's going to go left. If I have greater than, it's going to go right.
How do you feed him on the moon?
Oh.
I don't. He perseveres. He's a really strong fish.
What about Thanksgiving break?
That's why.
What's that?
What about Thanksgiving break?
Yeah, I know, I didn't feed him.
Christmas break?
We're not going to feed him.
How is he alive?
Summer vacation, or
Just feed him a lot.
he's gonna
Feed him a lot.
He eats them raw.
he's gonna go to the ocean before that.
What's an animal?
And then we'll get into
Well, guess who does?
All right, guys. Any questions? Any questions? Okay, I'm gonna keep going. Solving inequalities. Solve 2x minus 12 is greater than 5.
Oh, I remember this.
Hannah, what's my first step in solving something like this?
Add 12.
Add 12. Good. We're going to treat it just like a normal equation. Add 12. 2x is greater than 17. Mr. Casper, what's my next step?
Divide by 2.
Divide by 2. X is greater than 8.5. Good. That is my inequality. I've officially solved it, so I need to graph it. So like I said before, guys, there's a couple rules with graphing. First of all, if you draw a line, both sides of your line need to have arrows, right? It keeps going on and on. If you leave it without arrows, there's something really dumb to get points taken off for. So please make sure you put arrows at the end of your lines. Second thing, you need to have some sort of scale, right? They need to go all by ones, or all by twos, or all by threes. They can't just jump around. You can't have like 3, then 5, then 18, right? You need to have some sort of scale, all right? And I need to be able to see your endpoints in the direction your line is going. Those are the basic rules. So if I'm looking at 8.5 here, I'm going to start at 6, and I'm going to go by ones. 7, 8, 9, 10, 11. Right? I have a constant scale, I'm going by ones. I know when I put 8.5 on my graph here, I'm going to be able to see that endpoint, and I'm going greater than it, so I'm going to shade to the right. Remember, it's an open circle, it's not or equal to. Yes, sir?
Could you just do like 3 numbers so we don't have to write all these numbers?
Yeah, I would say 3 numbers would be the minimum. Okay? You have at least 3, but you can have more than 3 if you'd like. Like I said, though, if you only put 3, and you still need to have that constant scale.
Yeah.
Okay. All right. So, do you have to perfectly be right between 8 and 9 on your graph?
No.
No, it's an estimate, right? As long as you're close. Now, if you try and tell me that 8.5 is somewhere over here, we're gonna have a couple issues. All right. So, it's an estimate. I get it. All right. Second one. 2x minus 4 is greater than 12. Well, add 4. 2x greater than 16. Divide by 2. X is greater than 8. So I've solved it. And now I need a graph. So I'm going to start at, let's say, 6, again, 7, 8, 9, 10. Alright, so greater than 8. Well, open or close circle at 8? Open, right? It's not or equal to. Greater than means I'm shading it to the right. Perfect. Hey, this one's got another little caveat to it. It asks, what are 2 values that satisfy this inequality? So, Marissa, what's 1 that would satisfy that inequality? What?
9.
9. 9 would work. Haley, what's another?
10.
10. 10 would work. Kylie, what's another? 11 would work. Elijah, what's another? 12. 12 would work. Colin, what's another?
100.
100 would work. Perfect. Marissa, what's another?
2,369.
2,369 would work. Any questions? 8.0001 would work.
We did it.
Alright.
I know.
Hey, you guys do this one on your own. Do that one. You divide by -2. Guys, stop talking and do the problem. Hey, if I beat you to being done with the problem, we have to do push-ups.
Yes. Well, you're not going to beat me, so.
I can't do push-ups.
I'll give up.
I'm literally
You gonna learn.
Wait, if we beat you, can you do push-ups?
Yeah, I heard that too.
What's that?
I heard it. What? I don't
Jasper,
know.
do you want to do push-ups? Is that what I'm hearing?
I didn't say it. Hayden did not. I'm not
I
sure.
already
who
finished.
did, though.
Does that mean you have to do push-ups?
No, I'm not doing any push-ups.
But I beat you. I feel like that you should have to. I feel like most people have beat you, so I feel like you should do push-ups.
It's not right. Your graph's not right. Push-ups.
Wait, what? What?
Yep.
Hey, this works.
You have to do push-ups now.
I think Mr. E's about to. Yeah, what's wrong?
You guys check your answer mine when you're done.
I'm not done.
Hey, notice, why is it less than or equal to negative 2.5?
Because you put the side to the bottom of negative.
Shout. Why is it less than or equal to?
Oh my gosh.
Julia.
Because you divided by negative.
Hey guys, listen, Julia's trying to tell you something really important. Julia, can you please say it a little bit louder so we can hear you up front?
Yeah, you divided by a negative.
So we divided by a negative, which means we had to flip our sign. That's why it becomes less than or equal to negative 20.5. And then you need to graph it, right? Make sure you, guys, make sure you have a constant number. I went up by 2s. I started at negative 20.5, I went less than. And it was filled in because it was or equal to. Any questions? Cool, we got a lot more to go. Weird, you guys are whining again. Hey, yes, we still won't get to see our tests today.
Can we not have homework done?
No. We get extra homework. The other class didn't get any homework. Alright, guys, so, and or needs to satisfy both conditions, or only needs to satisfy on the one example I used last hour. Right, a real world example. If I say I need to go to the grocery store and the post office, that means I'm going to both of those two places. If I say I need to go to the grocery store or the post office, that means I need to go to only one of those, or I could go to both. You never know, right? So anytime I say or, it only needs to satisfy one of the two inequalities. If I say and, it needs to satisfy both of them. Alright? So if we look here, and we're trying to solve it, there are two types of and problems. There are ones where there's two inequalities with the word and in between them, like the first one here. And there's ones where it's a compound inequality, where there's three different parts to it. The first one, if I want to solve this so I can graph it, how do I do that? How do I solve something with two different inequalities in it? What do you think?
Do them separately.
Do them separately, right? So, subtract 2. 3x is less than 12. Divide by 3. X is less than 4. And plus 5. 2x greater than negative 6. Divide by 2. X is greater than negative 3.
The phone's ringing.
Thank
You're
you.
getting called onto the main office.
This is Eldridge. Hi there.
The lines are red.
Yep, that's what I thought. That is accurate.
Alright. I will let you know.
Yeah.
Oh my
Well, maybe she just arrived. Do you want me to send her back down to you?
There might be this.
On the camera. That's another first weekend.
Yeah, sure. He said it's okay to do for her, I guess.
As a wise man would say.
Hello?
Alright guys, if we're gonna graph this, right?
Yeah.
So,
Tell me give it.
x is less than 4 or x is greater than negative 3. You good? Alright. So, I know I need between negative 3 and 4, so when I put those numbers on my graph, I need to have those somewhere in there. So I'm going to start, let's go negative 4. I'm going to go by 2. So if x is less than 4, that means at 4 I'm going to put what type of circle? Open. And which way should I be shading? Left. X is greater than negative 3, so that means at negative 3 I should put what type of circle?
Right, open.
Open. And I should be shading right. Notice the overlap. In an AND problem, we should have two circles on either side, and we should shade in between the two of them, because that is the section where both of our restrictions are met. Right? Or both of our inequalities are met. So we said with an and, both of them need to happen. So our graph should look something like this. Alright, negative 15 less than or equal to negative 3x minus 21 less than or equal to 25. Oh, how do I solve like a compound one like this? There's two different ways to go about it, by the way. Marissa, what's the first way you think?
Don't you add 21 to like both, or like all three?
Yeah, so if you're going to solve it as a compound inequality, which is the way I prefer to do, you need to take, if I'm going to add 21 away from x, it needs to go to all three of these. Before I do that though, what do you think the second way is? What?
Separate them.
You can separate them, right? Negative 15 is less than or equal to negative 3x minus 21. Negative 3x minus 21 is less than or equal to 25. Put them into two inequalities. I prefer if you do it like this. 6 less than or equal to negative 3x less than or equal to 46. Divide by negative 3. Jared, what'd you say?
I said you gotta flip the sign.
Make sure you flip the signs. We're dividing by a negative. So negative 2 greater than or equal to x greater than or equal to negative 15 and 1/3.
Wow, they made
Dang,
it much
Mr. E. How'd you do that?
You
Oh,
memorized
you have the
it.
answer.
He's done it for other
15
classes.
times 3 is 45. Plus 1 is 47.
No, you.
No, you
I mean, I did it last hour, but it's... Alright, hey guys. Shh. Is that a good answer here?
No.
Join just is yes.
I would say no. Would I mark it wrong? Probably not. I prefer if you flip them around.
Oh,
So your smallest numbers all the way to the left. Negative 15 and 1/3 less than or equal to x less than or equal to negative 2. So that would be our inequality. So I know between negative 15 and 1/3 and negative 2 is that range I'm looking for. So I know on my graph I need to hit that range. So if I go negative 16, I'm going to go by 4s. Negative 12, negative 8, negative 4, 0. At negative 15 and 1/3, what type of circle am I going to make? Closed. Remember we said it's kind of like an estimate, so probably right about there. And I'm going to the right. At negative 2, what type of circle am I going to make? Closed. And I'm going to the left. So that is filled in. Remember, I'm filling in between the 2 points, my 2 endpoints. Your 2 endpoints must be on your graph.
So scary.
I can imagine. Good timing.
Because what if I wasn't here?
Well, then you probably would have been truant.
Probably.
Alright. Any questions on and problems? There's 2 types. Alright, then the or problem. Or, only to satisfy one of the conditions. You'll see it, it'll be broken up. 2 inequalities with the word or in between them. Just like you did at the first and problem, solve each separately. So you take minus 7, 2x is less than negative 18, and divide by 2. X is less than negative 9. Or, minus 2, 3x is greater than negative 15, divide by 3, x is greater than negative 5. So that's our inequality right there. Now we need to graph it. So I'm going to put my scale out here. I'm going to go, let's say, negative 10, negative 9, 8, 7, 6. Alright. The or graphs are going to look a little different, if you remember correctly. If I have x is less than negative 9, at negative 9 I'm putting what type of circle? Open, so it's not or equal to, and less than means I'm going to the left. X is greater than negative 5. Negative 5 I'm putting an open circle.
Arrow to the right.
I'm going to the right. So an or graph should have 2 endpoints, and our arrows going in different directions.
Yes, sir.
And we should be filling in between our 2 endpoints, or we're going opposite directions. That should happen 99.99999% of the time.
What about the
That
point? Oh.
0.0001 is when we have two endpoints. So like, let's say it was x is greater than -9 and x is less than -5. Then when I go to draw my graph, I have -9 greater than, -5 less than, and it's just an arrow across the whole thing. That's the only type of other or statement we should see.
Are we gonna see any of those?
We might. We might. We might. Alright. Any question on and or statements? We are not done.
I am.
You might be. Sure, dude. Alright.
Oh, there's another.
Reminder, like I just said, guys, and graphs should have 2 points filled in between, if I can go up to it. Or graphs will have points opposite directions. So, writing compound inequalities. This should take us 2 seconds. Once again, you didn't use Mississippi's. Hey, numbers 1 and 2, guys. What type of statement should they come out to? And statements, right? Because I have 2 dots and I'm connecting in between them. So, when you're writing an and statement, you can either write it as something and something, or you can write it as a compound inequality. Either one works. So when I look at my first endpoint, I know x is going to be something with -2. Well, am I going greater than, less than? Greater than -2, right? I'm going to the right of it. So it's greater than -2. And is it or equal to? No, it's an open circle, so it's not or equal to. So if x is greater than -2, and my other endpoint's at 1, and I'm going less than 1, is it or equal to?
Yes.
Yeah, it's a filled in dot. So that's an acceptable answer right there. Or you could put -2 less than x less than or equal to 1. You could write it as a compound inequality. Either one of those works. Alright, second one, same thing. It's an and problem. I have x is greater than -4, and it's or equal to because it's a filled in dot. And x is less than 5, or equal to, it's a filled in dot. So I can leave it as that. I can leave it as a statement with an and in between, or I can write it as a compound inequality. -4 less than or equal to x, less than or equal to 5. Alright, 3 and 4. What type of statement should these make?
Ors.
Or, right? I have 2 endpoints. I'm going in opposite directions. First one, my first endpoint's at -2. I'm going less than -2. I'm going to the left. So x is less than -2. Or, my second endpoint's at 0. I'm going to the right of 0, so it's greater than 0. Not or equal to, it's an open circle. Question?
Do you circle both of them?
Yeah. The whole thing is your statement. Okay? Number 4, first endpoint's at -2. So I look, I'm going to the left. It's less than -2, and it's a filled in circle, so it's or equal to. Or, my second endpoint's at 1. I'm going to the right, so it's greater than 1. It is not or equal to because it's an open circle. Alright, any questions on that? Alright, we have 2 more problems to do, I believe. Dos más. Special cases. What? Alright, how do I solve this special case?
It's not doing it.
Quit whining.
You can't.
I didn't.
What do you mean I can't?
You can't solve it.
Why not?
Unsolvable.
What's that?
It can't be bigger than 7
I don't
and less
know.
than 3. Oh, yeah.
Can it be bigger than what?
I already solved it, so.
Oh, you already solved it. How did you solve it, Elijah? Help us.
Oh, I added 2.
Added 2. Okay. So you got 4x is less than 12.
Yeah, and then x is less than 3.
Good, so you divide by 4. Good. X is less than 3. And solve the other one. -1. 3x is greater than 21. And divide by 3. X is greater than 7. Well, let's look for a second. Let's put this on the graph. So 1, 2, 3, 4, 5, 6, 7. Alright, so x is less than 3, so I'm putting an open circle at 3, and I'm going to the left, because it's less than. And x is greater than 7. Open circle at 7, going to the right, because it's greater than. That graph looks weird. It doesn't look like an AND graph.
Looks like a special case.
Hey, Haley, can you pick a number that works for those inequalities?
300.
2. Or
0.
Wrong.
None.
4, 5, 6.
Marissa, can you pick a number that works for those inequalities?
5.
Mm-mm.
None work.
None, right? Hey, think about this, guys. For an AND statement, we said it has to satisfy both inequalities. Is there any number you know of that is less than 3 and greater than 7?
Infinite.
No, right? There's no number that is less than 3, yet it's also greater than 7. So if you have an AND statement and it looks like an OR graph, no solution.
See?
Right? There's absolutely no solution that works here.
Yeah.
You have to write most.
No solution.
Can we just put an dash?
No.
Don't put no solution.
Don't be lazy.
Can we write unsolvable?
Yeah, and
No. No. Don't be lazy.
Can we put not possible?
No. No solution.
What if we start a number?
Alright. Last one. Let's solve this. First thing you need to do is distribute. I get negative 10 minus 12n less than 48 minus 12n. How do I solve that?
Well, it's going to be 0 and.
Well, how do you get 0n, Jared? Please tell me.
You
Add,
either.
Don't like it.
Abby, what do you think?
add 12 to each side.
Add 12n to each side. Guys. Hey, notice. All of my n's cancel out. I'm left with negative 10 is less than 48. Is that a true statement?
Yeah.
Is negative 10 less than 48?
Oh, yeah.
Yes. Because it is a true statement, my answer will be all
Solutions.
real numbers. Or all solutions I would accept as well. Right? Because no matter what number you plug in for n, it is going to work. You can pick any number you can think of. Plug it in for n, it'll be a true statement. Now, hey, what do you think happens if I cancel out all my variables and it's a false statement?
No solution.
No solution. Right? So if it's a false statement, it becomes no solution because nothing's going to work with it. Alright. Any questions?
We knocked it home.
What time we got here? 17? Perfect. I can hand out homework and then hand back the test and go through it.
No, we weren't getting our test today. Yeah. You liars.
Dang it, you
Mr. Would you like me to stop recording?
What's that?
Would you like me to stop recording?
Yeah, please.
Alright.
Swipe up. Swipe up.
Swipe up. Swipe up. Mr. E slipped on ketchup. Swipe up.